Hi there, my name is Nicole Sutherland. Welcome to Unix. Today I kind of want to tell you about what Unix is and the history of Unix. So I'm going to go ahead and get started with that. Okay, I'm going to start a little bit about the history, where it came from and where it is today. So eventually we're going to talk about the structure of the file system, what makes Unix Unix, in addition to some of the benefits of it as well. So, to start. Okay, so technically there is no Unix anymore. The operating system Unix itself was discontinued in the late 90s, early 2000s, but it was originally an operating system that was created between the 60s and the 80s in what's called Bell Labs, and that's at&t Bell Labs, which is named after Alexander Graham Bell himself, and it's now known as a little company called at&t. Okay, so this operating system took the technical world by storm. It was one of the first majorly distributed to other multiple groups as operating systems, and it has formed how almost every operating system is designed today. And that's except for Windows. Almost every operating system today has some callback to Unix, except for Windows. So, where did Unix come from? Well, we have to go back to the 1960s. It was a very, very popular back then to program operating systems because it was a new technology. Efforts were really made to build an operating system that could be deployed on multiple hardware platforms. Okay, so keeping that in mind, I want to talk a little bit about something called the Multics project. Professor Fernando Jose Corbato, hope I said that right, known to everyone as Corby, was the leader of the Multics development project at MIT. Okay, so Multics was this operating system project that was distributed across the country. MIT was writing a part of it, Berkeley Labs was writing a part of it, and Bell Labs was also writing some of it, okay? So this was an operating system that was designed to run huge servers and huge mainframes. So this took up the whole room, okay? Think about that. It took up the whole room and took 10 people to maintain. It had an entire air conditioning unit just to keep it cool. So Multics introduced some pretty cool stuff, okay? Like things like daemons that were programs that ran in the background and took care of all the tasks you wouldn't want to normally deal with, like logging in and making sure, like pixels are displayed on the screen. Another thing it introduced was something called dynamic linking. If any of you use C or Java before, that's the hashtag include or the import statement at the top of your program. So before Multics, you couldn't do that. You would just have to write everything in one file, and it was pretty awful. So unfortunately, the problem was a really bloated operating system with all this going on. So many different groups contributed to this, and they designed a system where there was a lot of redundancies in it. So there were 4 different ways to write a file to a terminal. And there was a lot, something called no process segmentation, which I'll talk about a little later. But basically meant that one person could completely trash another person's program, and there was no keeping, the people separate. So Bell Labs saw this and began to pull out. They were like, this is not a project that we're going to deal with. It was just too big and too many inconsistencies. They were like, this is not a good use of our time, so they began to take their engineers out of the project. And one of those engineers that they removed was a gentleman named Ken Thompson. Ken Thompson and also a gentleman named Dennis Ritchie are the Unix guys, okay? A lot of sources attribute them to being the founders of Unix. So Ken Thompson began this as a side project at at&t, okay? This was not their main project. So Multics failed, so he tried to figure out what went wrong about it. And he determined that the fact was it was so distributed and so many different parts were made without communication between people. So So what he did was inside at&t, Ken began building his own operating system, okay? And eventually his whole team started working on this project with him. So instead of a side project, this kind of became the main project, okay? The first release of this project was actually in 1969, and the name Unix was a pun on the name Multics because Multics was made with multiple people, okay? And therefore, since only one person made Unix, it was called Unix. So it ran on a huge program called PDP-11, okay? And one of the big problems during the first 3 years that they came across after Unix originally came out was, well, they hadn't developed a C compiler yet. And C was invented in 1971, okay? And if you're in my application programming class, you know what a compiler is, okay? It makes certain commands executable. So for the first 3 years, all of this operating system was written in an assembler. Okay, assembler is a very, very low-level language, okay? You specify every single instruction that the CPU runs. Ugh, it's really difficult. And it's really difficult to write, okay? And that's pretty wild that they took all the time and the dedication to write a whole operating system. So in 1971, the C compiler was invented, okay? And in 1972, Dennis Ritchie, one of the inventors of C, decided to help rewrite the Unix language, okay? I'm sorry, decided to rewrite Unix in this language, the C language. So that was a huge turning point for Unix because at that point, C could run on almost any operating system or any computer. And as long as the computer supported a C compiler, you could run Unix on it. Okay, it was incredible. Okay, game changer. So it allowed the Unix system to spread really prolifically. So through the 70s, Unix was distributed with its source code. And if you've ever heard the term open source, almost all programs back then were open source. Because computing was so new back then, there was no idea that, oh, I need to keep this code secret. So many people just assumed it was okay to distribute it and build upon it, okay? It was a really great practice that, unfortunately, is out of practice. So this code was picked up by a group of Berkeley students, okay? So now these students saw the operating system. They saw what they could do with it, and they thought, well, what if we take this one step further? We will develop it and integrate it. So we'll try to make everything part of the operating system kind of intertwined with each other. So thus this created BSD, the Berkeley Software Distribution. It actually grew up right alongside Unix and actually became quite popular. Now, obviously, it was oriented towards developers or developer-oriented people. It wasn't exactly, extremely user-friendly, but they did something called Unified Userland and kernel production, okay, which is basically what that means is instead of the two parts of where Unix developed separately, it was actually all developed as one in order to integrate even more tightly, okay. Unfortunately, in the 1980s, a gigantic legal battle ensued, okay? So there were all the people who liked Unix and all the people who liked BSD, and at&t came out and said, well, BSD is using part of our code, so let's sue them. So in response, BSD ripped out all of the Unix code and rewrote their own code and started to develop their own kind of path. And that's when BSD really started to fork away from Unix. So this was so it's the 80s for Unix, okay? And everything is still pretty underground, especially with the dawn of Windows. Okay, so companies like IBM, Hewlett-Packard restricted Unix during that time and made the programmers sign a non-disclosure agreement, okay? around that time, a gentleman called Richard Stallman, who worked for MIT, and y'all should look Richard Stallman up. I believe he's still alive. He's got a really big beard. Okay, anyway, he started writing code for a program he called GNU. GNU, okay? It means GNU's not Unix. Don't ask me why he came up with that. But anyway, Richard thought this program was so significant that he actually quit MIT, okay, and to make sure that it would not be able to gain copyright to this on the code that he wrote for GNU. Okay, so Richard Stallman actually launched GNU in 1984, okay? GNU is an operating system, okay, and it's an extensive collection of computer software. GNU is composed wholly of free software. GNU is an acronym for GNU's not Unix, like I mentioned. This acronym was chosen because GNU's design is Unix-like, but differs from Unix by being free software and containing no Unix code. So from the very beginning, the GNU project was operated as a nonprofit, with coding on a volunteer basis as much as possible, and with donated hardware and money, okay? So in 1987, an American computer scientist called Andrew Tannenbaum created Minix, short for Minimal Unix. It was sort of like BSD, except it was based on the idea that we want to create something, but we don't want to get sued by at&t, okay? So it was an implementation of Unix using a microkernel architecture. Minix is a text-oriented operating system with a kernel of less than 6,000 lines of code. Minix was really made for educational purposes so that universities could teach people about how operating systems work. Many universities used it as a training aid, and it's actually still in use today, surprisingly. So one of the students of a university that used Minix was a young man named Linus Torvald. Okay, he disliked how Minix was written, and so he created his own implementation of it using Richard Stallman's GNU. Okay, so in 1991, Linus Torvalds named it Linux for obvious reasons, his name. So Linux is a kernel. Okay, the program in the system that allocates the machine's resources to the other commands that you run. Okay, so the kernel, it's an essential part of the operating system, but it's pretty useless by itself. It can only function in the context of a complete operating system. So Linux is normally used in combination with the GNU operating system. The whole system is basically GNU with Linux added, or GNU Linux. So the biggest difference, and what you need to know, the biggest difference between Unix and Linux is the modularity of the kernel, okay? So there you have it. So next time we meet up, we're going to begin talking about installing the Linux system and its open source software. Great to have you. Welcome to Linux, Unix. Bye.